And we're rolling. Hope everybody's having a good day at home. Shout out, John. John, shout out. This is, I was going to say, this is to actually see if John Heap is actually watching the video.
If he watches it, it's going to be tomorrow morning.
John.
And when you come back, you have to say fruit.
John, if you're watching
okay, let's give John a code word. John, what is it?
Fruit Loops.
Fruit Loops. John, if you come up to me and say Fruit Loops, I will know that you have watched the review.
Get one extra credit.
The code word is Fruit Loops.
John, when you watch it, you got to text me.
Who else is out today?
Don't text us. Don't
Oh, Shrembeck. The code word is Fruit Loops. I think Shrembeck will watch the video.
I feel like you will, yeah.
Shrembeck will come up to me and say Fruit Loops.
Yeah, different.
And then people look at him and be like, what? All right, so let's take a look here. I am going to, again, if you're watching along at home, for anybody that's out, they're going to be showing up the answers on their boards. I'll be showing them so you guys can see them along the way, but just so you guys have all of the answers. Now, remember what you should be doing. You should be correcting every single problem as you go, because you're going to use this to study your study for tonight, okay? Please, 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 I cannot stress it enough. This is the first summative grade out of the third 9 weeks. Remember, summative grades that happen early on in the 9 weeks tend to stick for a while. So please, please, please give this your full effort, okay? All right, so who had numbers 1 and 2? Who had numbers 1 and 2? Okay. What was that? Was that your phone? Okay. You good?
Yeah.
What was that?
I feel like all
You actually called who?
almost.
Oh, okay, good.
I've done that. I've done
Never
that
a
so many
good.
times.
If you hit the power button 5 times in a row, it just gives you like a countdown.
Okay, I'm doing that right now.
No. Nobody tried that. Nobody tried that.
Taylor did that here. They had to come to school.
Oh my gosh. Okay, Tyler, you had numbers 1 and 2. Numbers 1 and 2 looks like these are the correct answers here. Find the power of 10. We got 1 with 7 zeros. People ended up 1 with 7 zeros. Good. And then remember that for 10 to the negative 6, you have 6 total zeros, including the ones to the left of the point. So 1, 2, 3, 4, 5, 6, and that's exactly what he has there. Very good. Those are the 2 answers there. So again, correct as you go. Correct as you go. 10 to the 7th power is 1 with 7 zeros on it. 10 to the negative 6 is 6 zeros and then a 1. Remember, negative exponent means a really small number. Numbers 3 and 4. You wrote them very small. Yes. 10 to the negative h power. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Looks like you do have 8 zeros there. And then 10 to the 2nd power is just 100. Yeah. But remember here for number 3, 10 to the negative 8, you see 0 points. 1, 2, 3, 4, 5, 6, 7, 8 total zeros. And then the 1 for number 4, 1, and then 2 zeros after it. Remember, positive exponents are big numbers. Negative exponents are small numbers. Again, you should be correcting your answers as you go. Okay, numbers 5 and 6. Who had 5 and 6? 10? Okay, for numbers 5 and 6, it looks like he has 10 to the negative 4th and then 10 to the 7th. And that's exactly what I have up here. Very good. 10 to the negative 4th, 10 to the 7th. There's not much work to show on that. Remember, you're just changing it from a decimal into a power of 10, or from a big number into a power of 10. So look, I've got 4 zeros here with my decimal, so it's 10 to the negative 4th. I've got 7 total zeros on the right side of the 1, so it's 10 to the 7th power. Questions about those two? Okay, and who had 7 and 8? Good. Now, before I get to that, I'm sorry, I thought these were more powers of 10. Are there any questions on 1 to 6? Are there any questions on 1 to 6? Hopefully those are like good grade boosters for you. Like give you some points there right at the beginning of the quiz so that you can, start off pretty good. Okay, so here's numbers. Any other questions? Good. Here's numbers 7 and 8. Looks like I've got 1 over 36 and 1 over 125. Good, those are good answers there. I've got it up on the board as well. It's 1 over negative 6 squared is 1 over 36. Please, please, please put that as a fraction. I had a lot of people giving me the answer is just 36. The answer is not just 36, it's 1 over 36. 1 over 36. Same thing there for number 8. It's 1 over 5 to the positive third power, so it's 1 over 125. Any questions on 7 and 8? Any questions on 7 and 8? Okay, let's keep it going. Who had 9 and 10? Good, Mason. I've got 4t to the third and 3 over g to the fourth. Good, delete that up there. Look at the a, it went to a positive 1. The t to the negative third goes from the bottom to the top. So it's 4 times 1 times t to the third, or just 4t to the third. And then number 10 there, it looks like the y to the 0 goes away because it's in the denominator, raised to a 0 power. The g to the negative fourth moves to the bottom to become g to the positive fourth. Good. Yeah.
For those ones with the 0 exponents, do you not have to like?
Write the 0 exponent. Right. You don't even have to write a 1.
Okay.
Yeah. I'm good if you don't write the 1, because if it just turns into a 1, it's like 1 times that thing and then it's done.
Okay.
Yeah. Any questions on through 10? Okay. Let's keep it going. Here is numbers 11 and 12. I know these are separated, but who had 11? Yeah, good. 3k to the 7th x and 6. Not much work to show again there. You're good. All you have to do is keep the 3 and the 3 on the top. The x goes to the denominator. The y will go away. The k or the x moves down. The k moves up. Positive 7th power. Who had number 12 there? Good. I've got 7t to the 5th over a to the 4th, b to the 3rd. Good. The 7 stays where it is. The a moves down. The b moves down. The c moves up. Remember, anything with a negative exponent will change direction. Anything with a negative exponent will change direction. It'll go from bottom to top or top to bottom, wherever it was from the beginning. Are we good with 11 and 12? Are we good with 11 and 12? Any questions on 11 and 12? Okay, numbers 13 and 14. In back, we got 30.5 times 10 to the 4th. Looks like we moved 4 places. 30. I think you got your comma in a weird spot for number 13. I think it's 305,000, I believe.
It is in the wrong spot.
I mean, the comma really doesn't matter. You got the right number of zeros there. 305,000. And then you're good with the next one, number 14.0403. Now, everybody focus up on the board real quick. Remember that for these problems, the power is how many times you're going to move the decimal. The power is how many times you're going to move the decimal. So for example, I've got this 0.5 sitting here. I want to move it to the right 4 spots because the power is 4. So if it's 30.5, I go right 1, 2, 3, 4. There's my new decimal. Fill in with 0. So that's why we have 305,000. Number 14, I had 403. Remember, the decimal place is right after the 3. And I want to move it to the left 4 units because it's a negative 4. So we go 1, 2, 3, and then 1 more. There's my new decimal place, 0.0403. Any questions on 13 or 14? Yes.
What is the decimal point after the 4?
No. You're thinking that you want to put it into like scientific notation. I just said find the value.
Okay.
Do you see the difference in the problem? Some of them say put it in scientific notation. That one you don't have to worry about that. All right. Who had 15 and 16? Back up there. Looks like 6.78 times 10 to the, let's say negative 7.
Yes.
And then 2.006 times 10 to the 8. That's what I had. Okay. Everybody look up here real quick. You're good, Travis. Thank you. You know that the decimal place needs to go right there. Remember, because that's scientific notation. It should go 1 digit, point, and then the rest of the number. So for example, here's 6.78. That's got to go right there. So how many times do I move it? Once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. And I've got to move it 7 times, and I'm making a really small number look bigger, so I've got to make a negative exponent. Negative exponents are small numbers. So 6.78 times 10 to the negative 7th power. 6.8 times 10 to the, 6.78 times 10 to the negative 7th power. Number 16 there, I've got 2.006. Again, 1 digit, then my decimal place, 2.006. How many times do I move it? Well, each comma is 3. So 3, 6, 2 more is 8. 10 to the 8th, positive 8th power. Number 17. Who had 17 and 18? Me, Baker, right? 17 and 18, looks like you've got negative 343, which is a good answer, and then 125 over 64. Those are both good answers there, thank you. Remember, negative 7 to the positive third power is just a negative number. You know what I had a lot of people try to tell me on number 7? 1 over 343. Can it be 1 over 343? No, because that's not a fraction. A negative number doesn't mean you put it into a fraction. A negative exponent means you put it into a fraction. So just because it turns out to be negative 343, you leave it as negative 343. Number 18, that is when you have to have a fraction. That goes into the denominator. 5 to the third is happy where it is. 8 squared goes into the denominator. It goes down and becomes positive. So 5 to the third is 125. 8 squared is 64. Okay. Questions there? All right. 19 and 20. Who had 19 and 20? Good. I've got a to the 11th, c to the 5th, p to the 5th, k to the 8th. Good. Those are good answers there. Guys, all you're doing here for number 19 is just multiplying with bases. Remember, the rule says, see, now we're getting into a lot more of those rules. The rule says, multiplying with the bases, I add the exponents. A to the third times a to the 8th is a to the 11th. And then we have a c to the 5th tagged on. And then the same thing here for number 20. K to the third and k to the 5th make k to the 8th. You don't combine it with the p to the 5th. That just stays there. Okay, questions about numbers 19 and 20? Yeah, question?
How does that make sense? I mean,
you're talking about the exponent property? Just basic here. If sorry, kind of do the same variable. If you've got this, right? The rule is that you add the exponents.
Yeah.
Right? And here's why. Because isn't this just x times x?
Yeah.
Isn't this just x times x times x?
Uh-huh.
So isn't this another way to write that as 1, 2, 3, 4, 5 of them?
Mm-hmm.
So that's the rule. So if you write it out, you would get that full number. So it's just that there that many times. So all you have to do is just add those two exponents together.
But which ones are you adding when there's 3?
You only take the
okay.
like bases.
Okay.
You only take like bases. Questions on 19 or 20? Anything else? Okay. Who's got 21? Who's got 21 and 22? 21 and 22. Good. 3.14 times 10 to the 17 times 600. Oops. Up on the next page. Got 1.884 times 10 to the 20. Good. And then 1.44. Uh-oh. I think that number's wrong. Do I have it? Is that the same problem? Yeah. So for number 22, it should be 2. Maybe my key's wrong. 2.06. Whoa. 2.06 times 7.02. You take the numbers and multiply them. Yeah. You should get 14.4612. And then you take, so 14 times 10 to the, and then you add the exponents. -4 and 12 make 8. And then you got to put it back into scientific notation. So this needs to move one more unit to the left. So it's 1.44612 times 10 to the positive 9. Now, I have a lot of people saying, can I just do this in my calculator? Yeah. My calculator is going to look a little different, but you can do this whole 2.06 times 10 to the -4th times 7.02 times 10 to the 12. And guess what you're going to get? That number. Now, it's never going to, well, I can't say never. It's usually not going to put it into scientific notation for you. You have to do that. Okay? The only trick is just make sure that you're putting it in parentheses, like I am here. Okay? All right, who's got 23? Got 23 and 24. Looks like we've got 1 over x to the 27th, 1 over a to the 18th into 18th. Yeah, good. Those are good answers there. Remember that power to a power means we multiply, right? That's the rule there. Power to a power means we multiply. So negative 5 times 7 is negative 35. And then, see, we're layering two properties with power to a power. And then the product rule, we add the exponents up top, so negative 27. You know what, guys, look at me right now, please. I need everybody's eyes. I don't want it to happen, but people are going to write this on the answer blank tomorrow. You're so close. You did the problem correct. But can you write a negative exponent on an answer line? No. The only time you can is when I'm putting in scientific notation, doing powers of 10 or something like that. You cannot leave a negative exponent like that. It has to go down into the denominator. And it's such a shame because you guys do so good on like a full problem, and then it's like, oh, you didn't put it down into the denominator. Okay. Same thing for number 24. Power to power here, we multiply the negative 12. The reason why I put you up in front so I can see you. I know, that's why I'm telling you not to do that. 4 times negative 3 is a negative 12. Negative 6 and negative 12 make negative 18. So 1 over a to the 18th power. Any questions on 23 or 24? Okay, let's keep it going. Who's got 25? Oh, you got 25 and 26? Good. So remember, the property here is I subtract. So he's got b to the 7th, which is good. 10 minus 3 is b to the 7th. And then we've got 3 minus 9, you get x to the negative 6. That must come down into the denominator like he did, 1 over x to the positive 6. Good. Thank you. Moving on to 27 and 28. Who's got 27 and 28? You got 3k to the 6. Oh, be careful there. Uh-oh. Let's take a look at these. Liam, you're good with distributing the power, but you didn't actually write 3 to the 3rd. You just kept it as a 3. You got to actually evaluate 3 to the 3rd, which is 27.
Oh.
So it needs to be
27.
27k to the 9. Does that make sense?
Yeah.
Also here, I don't think you took negative 2 to the 4th power. You got to distribute that power in. Negative 2 to the 4th is 16. I don't know where you got that. I don't know where you got that. So it's 16, and then you've got a power to power here that should have a power of 32. 8 times 4 is 32. 16y to the 32nd power. Questions on those two, 27 or 28? Okay, number 29 back there. Thank you, Elena. Looks like we've got x to the 3rd, y to the 6th, and that's a good answer there. X to the 3rd, y to the 6th. Let me just do this. Yeah, there we go. X to the 3rd, y to the 6th. Don't forget, there is a step here. Don't forget to put that in, distribute that in before you start subtracting. You've got to make it x to the 6th, y to the 9th over x to the 3rd, y to the 3rd, which is x to the 3rd, y to the 6th. Subtract here, subtract here. So 9 minus 3 is 6, y to the 6th. Wait, number 30? 30, you got number 30? Good. Hold on a second. Might just be reading it wrong. Nope, you're good. B to the 3rd over a to the 5th. Good. We distributed the 8. Oh, that's why. That's a 3 on top. You got your answer right because you wrote the original one. It's a to the 3rd, B to the 11th. It doesn't really matter though. A to the 3rd, B to the 11th over 8. Sorry, A to the 8th, B to the 8th. Remember, distribute that power in. So you're going to have a to the 3rd over a to the 8th, which is an a to the negative 5th power. 11 minus 8 is 3, so b to the 3rd. Don't forget, layer those properties. That negative exponent has to come down a to the 5th. Okay, who's got 31? Okay. We bring in, we got 3 to the 3rd, 27. Is that p to the 15th? Did you write that?
For this or that one? The first one. Like the first part or the second part, like the answer part?
What'd you write? P to the what?
15 for the first part, and then for the final part, P to the third.
Okay, that P to the third should be on top.
Oh.
Yeah. Because, yeah, I this side here. That P to the third should be on top, because it's positive 3. Okay. But again, most of that was really good. 3 to the third. Actually, you know what I could have done differently? Could I have simplified this before I brought in my third power? Yeah, I could have made this 3p over q to the 7th and then distribute in the power of 3. Right? Liam, wake up. I could have raised that now, everything to the power of 3. So 3 to the third, p to the third, q to the 21st. And then I just got to take that 3 to the third. I have a lot of people always asking me, do I actually raise those numbers to the power? Yes. Actually evaluate out 3 to the third and see what you get. Okay? Don't just leave it as 3 to the third. All right. Over here, who's got 32? Got 10, a to the, is that the a to the 6th? No, all the way at the bottom.
Yeah.
Okay. It shouldn't be 10. It's 5 squared, not 5 times 2. So it should be 25. A to the 6th over c to the 8th. But all the work with the variables is good. So make note of that. A lot of people would try to tell me 10 a to the 6th over c to the 8th. Because when you distribute that power of 2 in, you're not just multiplying the 2 times the 5. You're taking 5 squared, right? And then we would have a to the 3rd, so a to the 6th over c to the 8th. Good. And then my last two, handing out my last two. B to the 3rd over 27 and h to the 9th over g to the 9th. Good. Those are good, two good answers there. Thank you. Remember, what do you do with the negative exponent? You flip it, right? So the negative exponent flips the fraction on the inside. You should have b over 3 to the positive 3 power. So b to the 3rd, 3 to the 3rd, so b to the 3rd over 27. And then g over h should turn into h over g, all raised to the 9th, so h to the 9th over g to the 9th. Okay, questions on anything on the practice quiz?
9.
Number 9?
That was funny. I got it.
Anything on the practice quiz? Okay, you should know what you need to study. Okay, study the practice quiz. Remember, first grade is a new 9 weeks. Make it count. So long, everybody at home. Remember, John, Fruit Loops. Fruit Loops.
Fruit Loop.